We're going to take a little side trip today, and I'm going to talk about a couple different things, and then I'm going to give you your handout on magnetism. We are going to get to that second question, what is magnetism, and then later on how it's related to what we've talked about. But there's some interesting things going on with electricity right now, trying to deal with the oil crisis. Head up, please. And so I'm going to be talking about these two things. I'm going to talk about the fuel cell and electrolysis. And I'm going to ask you a question right now. Is it possible to light water on fire?
Yeah.
I don't mean put oil on top and light that on fire. I mean actually light H2O on fire.
Yeah.
I hear yeses and I see some heads shaking saying no.
Yeah.
Would you be impressed if I could light water on fire?
That would be crazy.
Okay. Well, you should be, because that's pretty impressive. And I'm going to start an experiment over here right now. You can see up on the TV. Well, maybe you can't see. I'm looking for bubbles.
I can't see it.
Yes, you can't see. No, it's not going to show up, guys. It's too cloudy. So we won't worry about that. But I'm starting a little experiment here, which I'll explain in a little bit. And hopefully at the end of the period, I'll be able to show you that you can, in fact, light water on fire. And it has to do with this thing called electrolysis. So we'll talk about that. And we're also going to talk about kind of the opposite of electrolysis, a fuel cell and how they work and how they're going to be important in your future. Okay? But before we do that, one of the concepts that just really didn't seem to get across to you was this idea of current and voltage. You guys seem to have some understanding of the resistance part, but not the current and voltage. Okay? So I said water's a good way to illustrate it. It's not a perfect way, but it's better than many. And what I tried to show here is different kinds of water flow. Remember that the A, the current, represents what? 3 words. Rate of flow. That means how many gallons per minute. How much water is actually coming out of that pipe. Okay? If it were electrons, how many electrons are going to come by in a certain amount of time? Voltage would be like the pressure. Boy, we just forgot this from 5 minutes ago, guys. So on each of these, you should be able to look at these illustrations and tell me, in this first example, would you call that current, the rate of flow, high or low? What would you call the voltage? High. How about in this one? Current is?
High.
Voltage is?
High.
What about in this one? Current is?
Low.
Voltage is?
Low.
And in this one, current is?
High.
And voltage is?
Low.
Okay, so we're getting a lot of water out every minute here, but it's not shooting with tremendous force like maybe a fire hose might do. If you could picture this and you understand why we say high and low current, high and low voltage here, you pretty much have it. And all we do when we add the resistance part is if I were to go back here and squeeze the hose, I'm adding or taking away resistance? Adding. It would be like having a smaller wire. The electrons are going to get crowded trying to get through that wire. And it's going to do what to the flow? Slow it down. It's going to do what to the current? Guys, the current is the flow. What does it do to the flow? What does it do to the current? Slow it down. I mean, if you squeeze on that hose, you can imagine that it's going to slow it down. Now, some people take it a little too literally. They think, oh, well then if you squeeze on a wire, you're going to slow down the flow. Okay? A wire is not hollow, and electrons are not like water in terms of, going through this hole in the inside. Squeezing on a wire isn't going to slow down that flow. It's not going to affect it at all. Curling it up, for the most part, isn't going to make any difference. There were 3 things we talked about to increase the resistance. Making the wire longer, making it longer increases the resistance. Making it smaller and changing to a different material, something that's got more resistance in it. Zach?
How come the diameter of the wire changes it? Did you say that like days ago?
How come the diameter of the wire what?
Like changes it?
It does. Making the wire smaller. That's changing
Isn't
the
that like
diameter.
squeezing it though?
No, that's not like squeezing it. It's having less copper.
Oh, okay.
Okay? So if my wire's this big around, like the wires that come in overhead to your neighborhood, they're this big around, it's like a bigger highway. A lot more metal there, a lot more copper if it's copper, to carry the electrons. It's like a super highway. When it gets to your house and it comes through these tiny little wires here, we don't need a super highway. You don't need a freeway system to go directly to your front door, okay? Because you don't have a million cars a day coming up to your house. So as we get farther from the freeway, the roads get smaller and smaller until you get to your neighborhood, and smaller still. Kind of sounds like arteries and arterioles. Remember all that from human anatomy? You want to spit out your gum, Zach? Thank you. All right. So I want to share with you these two things, electrolysis and a... Thank you. Yesterday we had a battery, we had an electrolyte. I still do. This time the electrolyte's water with some salts dissolved in it. And we had electrodes, 2 pieces of metal, and we use that to produce electricity. This is kind of like a battery in reverse. I'm actually going to hook it up, it already has been running, I'm going to hook it up to electricity, and I'm going to run electricity to 2 wires, 2 electrodes. Those electrodes right now are sitting, the wires go down and they hook at the end like this. And they're sitting inside a syringe, okay? And what's happening is because of the electricity flowing through the wire, it's actually taking the water that's inside that syringe and it's splitting it. This is what we call electrolysis. Electro means electricity. Lysis is a good word to know. You'll learn that in medicine, you'll learn that in a lot of different areas. It means to split or separate. And so what we're doing in electrolysis is we're separating water. And water is made up of 2 things. What are they?
Hydrogen and oxygen.
Hydrogen and oxygen. 2 parts hydrogen, 1 part oxygen. And isn't it interesting that if I had just hydrogen, what state of matter would it be in? Most often? Gas. If I had just oxygen, it would be gas. You take 2 gases and you combine them together, and now their natural state is liquid. That's pretty interesting. It's also interesting that hydrogen is highly flammable. Look at the Hindenburg if you've ever seen that footage. Oxygen. Well, oxygen you have to have if you're going to have a flame. So here we have 2 things that burst into flame. We put them together and they make a liquid that we use to put out a flame. Nathan?
Well, can't hydrogen be liquid too?
Yeah. You can liquefy oxygen as well. So they can be in liquid forms. But what I'm saying is that a lot of people think they're always gases. You're absolutely right. They can be turned into liquids under the right amount of pressure. At certain temperatures, things change state. They go from being a solid to a liquid to a gas. Okay? But what we're doing here is by running electricity through those wires, we're splitting water. They use the technology of electrolysis to remove hair. Ladies, you might have heard of electrolysis used to remove hair. It's supposed to be a semi-permanent way of getting rid of unwanted hair. And they use electrical signals, electrical shock, if you will, to separate the hair from its root. And then you don't have to shave as often. Okay? So you'll hear that word again, but in the way I'm using it, we're doing electrolysis of water. I'm separating water. And right now, building up in this tube, hopefully, is gas. Hydrogen, I'm not getting a lot, I'm getting some. Hydrogen and oxygen gas. And if this works, I will collect enough that I can squirt out that gas, the hydrogen-oxygen gas, under this liquid. This is a bubble solution. And I want to form little bubbles. And then we're going to light those bubbles on fire. Prove that you can light water on fire. Okay? We'll see if that works for us. So that's electrolysis. And this technology has been around a long time. You can do all sorts of cool things with electricity that a lot of people don't even realize. The second thing I have up here is a fuel cell. And if you look at my illustration up there on the board, basically we've got a tank of hydrogen, a tank of oxygen, and they're separated by this membrane of platinum. It's one of the things that makes fuel cells expensive. And what happens in a fuel cell is almost the opposite of what happens in electrolysis. In electrolysis, I'm using electricity to create hydrogen and oxygen. In a fuel cell, I'm taking hydrogen and oxygen and I'm combining them. And what do you think I'm going to get when I combine them? Water. When you combine hydrogen and oxygen, you're going to get water. Okay? I'm going to get water, and my byproduct, the other thing I'm going to get is, what's the E minus stand for?
Electrons.
Electrons. I'm going to get electrons flowing, also known as, electrons flowing is also known as electricity. Okay? So the cool thing about a fuel cell is that unlike, when you burn gas for your car, where it gives off carbon monoxide and all these nasty chemicals that can kill you, when you're running a fuel cell and you're combining hydrogen and oxygen together, the only thing coming out of the tailpipe is water. Okay? And you're making clean electricity. That electricity can then be used to run an electric motor to power your vehicle. Okay? Now, that's where a lot of people stop. They tell this to little kids, and little kids think, well, this is the solution to all our problems. It's a little more complicated than that. Because in order for my fuel cell to work, I need hydrogen and oxygen. I need them to be separate. In order to be separate, over here, I had to use some energy, electricity, to split them. So somebody's going to have to do the work for me. Someone's going to have to fill up my tank with hydrogen. And how are they going to get just pure hydrogen? Well, they can get it from the air, they can get it from water, but that takes energy. If I want to get hydrogen like I'm getting over here, that took electricity. And the electricity comes from, where does this go to? The power plant. And the power plant may be doing things like burning fossil fuels to make the electricity. So you see how we really haven't solved the problem, we just moved it to another location. Now I have to have the power company has to make more electricity so I can make my hydrogen so that my car can run off of hydrogen. Or I could just, use less electricity and do it right here. So it doesn't solve the problem right there. But what if there was a way to produce hydrogen without using gas and other fuels like fossil fuels that are going to run out? And that's what leads to this little demo here. This would be an ideal situation. The holy grail, the thing that all scientists would love to develop is a way of producing free energy. So you could have all the electricity, all the energy your car needed, and it wouldn't cost a penny, and you could renew it. Okay? The problem with oil and some of the fuels we use now is it's going to run out. Unless a whole bunch more dinosaurs die, and then we can go back in time and get their remains, we're out of luck. There's only so much oil out there, and eventually it's going to be gone. In the next 20 years, 20 to 40 years, they're anticipating all the oil will be gone. So we don't have a choice. We have to switch from fossil fuels. We can't continue to go the way we are. And you might have heard about solar cars. Well, a solar car doesn't just run off of solar power. It has to have a way of storing this energy, because a solar panel right now cannot give your car enough oomph, enough flow, current, to keep it going. And what happens when it's not a bright day? What happens at nighttime? So you need a way to store the energy. So what we do is we put batteries in the car, right? Well, that's fine. You can charge up the battery. Maybe you could charge it up from the solar cell, but you've got to leave your car out in the sun and hope that you get enough sun that day to charge up your batteries. If not, you're back to plugging into the wall. And we're right back where we started. So another option is, okay, we use the solar cell. Solar cell maybe goes up on your roof, so you can put your car in the garage and charges the batteries. Eventually those batteries will die and they will recharge. All batteries have a certain amount of times that you can recharge them, and then they're no longer good. What do we do with them then? We throw them in the trash, right? Put them in a landfill. And in a landfill then, the batteries, the water, it rains on the landfill, the water goes down and it takes the lead from the batteries, it takes the mercury and all these poisonous chemicals, and it brings it down into our drinking water. And then you end up drinking it, and you end up having babies with birth defects or 6 arms or whatever the case may be because of those chemicals. So that's not a perfect solution. Even an electric car is not a perfect solution. The best thing would be to have some sort of vehicle that didn't have batteries, that we could fuel up on something like, oh, I don't know, water, that would last as long as we have sun. And that's how this system's supposed to work. So imagine this in our future world. We already have cars with fuel cells. They're coming out, okay? But what happens is someone has to give you the hydrogen. So you have to go pay, and then how are they making the hydrogen? Where is that electricity coming from? If it can come from a solar panel, that's ideal. So imagine this is your gas station. All that gas station needs is a supply of water, the most abundant substance on the surface of the earth. We put it in there, and we use the solar panel to create electricity, and the electricity does what I'm doing over here. Splits the hydrogen and oxygen. When I turn this on, you'll see, got little flashing lights to give you a cool effect, but you'll see little bubbles should start to come out on this side, and that's showing me that it is working. That's the oxygen coming off. We don't need to save the oxygen because we can pull oxygen right out of the air. What we need to get is that pure hydrogen. So the hydrogen it's making is coming out of this tube and fueling up the car. You can see that this little blue thing is getting bigger and bigger, and it's filling up with hydrogen right now. Okay? And this gets stored in some sort of tank, so you drive up your car, you hook it up, and it's making its own supply, but the tank never runs out. As long as you've got water, you can make hydrogen. You got water and sunlight, you can make hydrogen. Yes?
But then, if your car caught on fire, you'd be like,
This is one of the reasons. Fuel cells have been around since the space age, since the 60s, to power spacecraft. But the scary thing was, could we fit enough hydrogen in a car so you could drive a couple hundred miles, like you can in current cars? And they had to do that, they had to compress it. And then the tanks had to be very strong. And then they were afraid, what happens when you get hit? You're absolutely right. Would the tank blow up and there'd be this inferno and everyone would die horribly? So they've now improved the design of the tanks and the way to compress it into the tank. So now that's full. I can take this off, and I have a tank of hydrogen. There's nothing else in here. There's no batteries of any kind, no solar panels, just my fuel cell. When I turn it on, it's going to take the hydrogen, it's going to combine it with the oxygen in the air, and out of this little thing I'll get some water vapor. You won't even notice it, it's such a small amount. And it's making electricity. No pollution of any kind. And all the energy can be traced back to what source?
Water.
The sun. The sun split the gas, or split the water to give me the two gases. We stored one of them on board our car, and then we just used that with the fuel cell to create pure electricity and water. Not a bad solution, okay? But that means all the gas stations and all the gas companies that make, and oil companies that make all this money are now going to have to accept the fact that we're not going to support that any longer. We want to build these things. Or better still, wouldn't it be cool if you could build this into your car? So all you do is fill up your car with, the tank never runs out. So it's only a small amount. You haven't seen this before because no one does this. This is my own little patented method. Okay? Not like this, not with soap bubbles, not in a syringe like this. So that small amount you see of gas at the top should be hydrogen and oxygen gas. And we should form some bubbles here when I eject it. And those are the ones that we want to... I didn't get many bubbles.
am I doing it?
Not going to be too impressive, but go ahead, light those bubbles. There we go. That was just a couple tablespoons of hydrogen and oxygen gas. Pretty...